All right. Well, welcome everyone to the basic weed identification portions of the foundation to crop scouting training that we've been hosting the last few weeks. At any time, please feel free to put questions and comments in the chat. So, moving into the presentation itself, um, we want to think about weed management in a couple different ways when we're out scouting. First off, I really like the field scouting report that Liz Gartman has put together, along with the help of, I'm sure, others and many years of experience. But we're going to pay attention to the weed section today. In that crop scouting form, we first list the weed species we're looking at. So for the photos on the screen, that would be dandelion. And then there's also winter rye. And I put winter rye on there because many times we're scouting fields that may have a cover crop and we need to terminate that cover crop possibly. So we're gonna note those because the pressure and density of those, along with the height, is very important for timely termination of our weeds. So we write down dandelions. For a dandelion, we typically record how wide it is. For the height and the pressure, in that photo, it's tough to say pressure because you'll see a couple different things. One of which is the dandelions are kind of confined to the edges of the photo. And throughout those middle rows, there's maybe one or two dandelions per foot squared. So that's one of the challenges that we're going to talk through more is talking about that pressure and how to actually look at weed pressure out in the field. And then finally, weed height is really important. So we're going to talk a lot about weed height in the next few slides. 2 to 4 inch weed height is critical for timely termination. The photo there on the left-hand side of the screen is a Palmer amaranth plant, and that Palmer amaranth plant essentially was not terminated because it was too large at the time that it was sprayed with a herbicide. So even our best herbicides are going to struggle with terminating those tough weeds if they're above 4 inches in height. So taking a tape measure along with your weed ID skills is going to be pretty critical in making these weed management decisions. So weed pressure and density. The best way to see weed pressure typically is using some aerial imagery. So taking the drone up and looking at the field, and you're going to be able to see those big weeds late in the summer. That's going to be a very clear illustration of weed pressure. Earlier in the spring, weed pressure is going to look like a green field. The corn and the weeds, or the soybeans and the weeds, are going to be all virtually the same color from the road. You're going to have a green field out there. So we're going to have to get out and scout those fields. The photo that I have there with the PVC quadrant in the lower right-hand side of the screen, that's what we use to talk about weed pressure. And we actually count all those weeds in that defined dimension, typically a quarter meter square. Sometimes that varies as well, depending on what we're looking at. But in that quarter meter square, we may have 40 giant ragweed, and we may have 30 common ragweed, and we may have 20 water hemp. And we'd record that. And that's going to vary from plot to plot as we're doing our research studies. But for using this out in the field, having some sort of standardized sampling protocol allows us to just compare areas and compare fields. So say we have that quarter meter quadrant we built out of PVC pipe, we can throw that out in the field and count our weeds and say, well, we've got 4 water hemp plants, a little bit of grass pressure, fairly clean field. We go to another field, we may have 40 water hemp plants in the same quadrant. But we're also going to have patchiness, as that UAV photo allows us to see patches of water hemp. As one water hemp plant produces seed, the next season there's going to be a patch of water hemp around that plant. That's common for virtually all of our weed species. We want to pay really special attention to troublesome weeds like water hemp, palmer amaranth, and ragweeds. These should always be controlled to reduce the chance of weed production, regardless of the pressure present. So even if we have very low pressure, we really need to be controlling those troublesome weeds because they can cause severe yield damage in very short time. Canada thistle and bindweeds often form patches out in the field, as does field horsetail. So we'll see those patches of weeds out in the field that we'll probably even be able to see from the road. That has to do with the nature of those weeds' growth and development. The university has provided a little bit of guidance over time about weed pressure out in the field. Scattered is when we have a few weeds present throughout the entire field. Slight weed pressure is when we have, say, an average of no more than one plant per 3 feet of row feet. Moderate is a uniform concentration of weeds across the field, and then severe is more than one plant per foot. And I oftentimes see this very severe infestation occurring with giant ragweed and water hemp both when I'm out in the field. We're also thinking about timing when we're thinking about scouting for weeds. Oftentimes, we are looking at weeds prior to or after herbicide application, or row cultivation, or field cultivation pass. Some sort of control tactic. We're going out to the field to see what kind of weeds we have, how big they are, or if our control tactic worked. So in no-till fields, we're thinking about early season weeds like dandelions and mare's tail and shepherd's purse. Tillage is going to eliminate many of our small-seeded broadleafs and our grasses, so we don't have to worry about some of these early weeds in our grass fields. Pre's are going to control weeds for approximately 30 days, but I have seen pre's work for up to 60 days before. And then the post needs to be applied at 2 to 4 inch weed height. So that's where that constant scouting comes in. So what's our exact timing for weed scouting? We first want to be really paying attention to the pesticide reentry interval, the REI. That's a legal requirement and that protects our safety. So if a previous pesticide was applied to this field, we need to know about it. We need to know when it would be safe to go back into that field. We're going to be scouting prior to crop planting in many times, unless we are doing a clean tillage pass, because oftentimes in our premix we may be including a burn down, and this is true with our cover crop species as well. If we're trying to terminate a winter rye, we may have some dandelions hanging out underneath that winter rye. In that case, we'd want to include a growth regulator herbicide. We're going to be scouting shortly after crop emergence. We're going to be looking for any herbicide injury that may have occurred to that plant, and we're also going to be scouting to see what kind of weeds are emerging now. We're going to be scouting weekly until control options are no longer available. I really like the chart on the left. It's for wheat, but it shows the cutoff dates for different herbicides based on growth stage. And the same is true for corn and soybeans. I just couldn't find a good chart for it. So there's cutoffs for different herbicides that coincide with the growth stages. We also are limited by crop canopy cover. So once we reach crop canopy cover for corn and soybeans, we're typically not as worried about weed control, but the more we have to go into that field, the more damage we cause, and especially say narrow row soybeans. So we want to be paying attention to things like that as well. The crop canopy cover is an asset though for weed management. So when we're going out to the field, we're going to walk a W throughout the field. I've got the chance to work for the same company in Northern Illinois for 4 summers, and I was able to walk many fields. And we were scouting for weeds. We were just looking for spray timing, see how big the weeds were, what kind of species we had out there. So we'd walk through the field randomly and sample for weeds. We want to pay attention to special areas, areas of the field that may contain more weeds or harder to get to. Oftentimes along waterways or fence rows, we may have some weed escapes over time, and those may form some troublesome spots. So again, the UAV imagery helps us narrow down some of those fields as well. If there are only few weeds that are present, there's going to be more emerging unless there was a, say, pre-emergent herbicide applied. So be ready to come back to that field and be ready to have a timely application made to that if you're making those decisions as well. We're going to also use the field history. So in the lower left-hand photo, that's water hemp at the Lancaster farm. And you can see those nice long lines that are parallel to the soybean rows. That was made by a combine pass the previous few years, harvesting soybeans and corn, but also harvesting water hemp plants and putting those seeds throughout the field. So we know in the fall that next year we're going to grow corn in that field. We have a water hemp problem. We need to be scouting for water hemp. Weed history and troublesome weeds, a little bit more on that. Some weeds to pay particular attention to, Palmer amaranth. That photo is of me with a Palmer amaranth plant Josh Camps took a few years ago. Palmer amaranth is very aggressive and produces thousands of seeds. Water hemp also produces thousands of seeds. That's the far right-hand photo. So if we have those weeds going to seed the previous year, we need to have a plan, but we also need to have a plan for scouting of those weeds. We have foxtail species there mentioned. Foxtail can be a challenging weed for us in Wisconsin. We're fortunate that glyphosate typically will control that weed, but if we have a lot of grass pressure in the system, we need to be thinking about how we're going to scout and then control that. And then finally, you may be driving down the road and see fields that look like this giant ragweed field in the soybean patch. And we really need to be worried about that for next year as well. But pay attention to those patches. Those patches are maybe close to the road, but if you look further out in the field, there's some big patches a long ways off the field. So if we're just jumping out of the truck, taking a quick look along the road, we may or may not see those patches. Therefore, we may be providing inaccurate information on our scouting reports. A few books that I think are worth reading and referencing as we're at our desks and then possibly bringing to the field, but not in all cases. This isn't an endorsement of these. These are just books that I've read. Weeds in the Northeast was a foundational book for us in college. That's a weed identification guide for many, many weeds. There's also Weeds in the Midwest, a fairly similar book. These books provide some photos of the seedling and the mature seed heads along with the mature weeds for many, many species we see. Can be a little bit overwhelming though. So that's where the three other choices come in. Weed identification and herbicide injury guide from Missouri is a great guide. Um, these you do unfortunately have to pay for, but I think they provide some really relevant information for us in the Midwest. Managing Weeds on Your Farm is a free SARE publication via PDF. I think it's outstanding and has many relevant points of information that we can think about. And finally, the Weed Identification Guide from Iowa State is more of a pocket guide that we could be taking to the field. And then finally, we have a few resources that are free to us. The Field Crop Scouting Manual. Jordan's going to be posting a link to that in the chat. Common Weed Seedlings of the North Central States is also a publication you can typically find online as a PDF. These two publications will really provide us all the information that we need to see many of the common weeds in Wisconsin. The other publications really help us with those species that we may or may not see. And then finally, the weed guide for Ontario crops. Again, not an endorsement of this publication, but it's a free PDF. And I thought that was pretty cool that they had a free book that had actually quite a few common weeds for us in Wisconsin that we could be referencing. I get this question a lot. I learned this technique a few years ago from my spouse, who's a horticulturist, and that's using your iPhone to identify weeds. And Android has similar apps as well. There's also dedicated apps that you can get to identify weeds. This was a tool that I used with Josh Camps when we were out in the field a few weeks ago. We had a plant that was common in a forest setting, actually growing out in a no-till field. Took a photo of it. It seemed to be fairly accurate. I went back and looked up the weed at home, and it was actually spot on. Not an endorsement of these tools because I think they can be challenged when we take them out in the field because, as you'll see, the weeds look really different depending on what time of year it is, depending on environmental conditions. But I just took this the other day. It was a lamb's quarter growing in a driveway. Took the photo, and then you click on the little plant icon that pops up in the bottom of the iPhone settings portion. It says it's a plant. You can click on look up a plant, and there it is. Lamb's quarters comes up. So it's a cool tool if you're out in the field and you have no idea what it is. May help you provide a little bit of guidance. So moving into the actual ID of weeds, and grass ID is my favorite. Grasses were the first thing that I learned how to identify out on that crop scouting internship. The very first year, I got a grass key. I believe I still have that same key in my desk drawer today. So I would recommend printing off one. There's many available, including in the crop scouting guide, which again, the link will be in the chat. There's a few things to look at on this key, and they all look a little bit different, but they're all similar. First off, we need to know the terminology of a grass plant. We need to know that the leaf blade, and we need to be looking at the top side and the bottom side of the leaf blade. We need to know where the auricles may or may not be. We need to know where the ligule may or may not be. The leaf collar. Those are the main things we look at. The stem is also important, but the stem is going to be primarily to distinguish grasses from yellow nutsedge. The nutsedge will have an edge to the leaf and it'll be flat. We'll talk about that more here coming up. So looking at the leaf blade here in a little bit more detail, we're going to look at the leaf blade for hairs on the leaf on the top side or the bottom side. We're going to be looking for a ligule, which could be absent, could be membranous, it could be hairy, or there could be a fringe of hairs at the base of the ligule. We're going to be looking to see if auricles are present, and we're going to be looking at the sheath. We're going to be looking at the ligule types, and those are the ones I just ran through, and then finally the ligule margins. So these are going to be key to grass identification, and any grass that you find in a common crop field in Wisconsin, you'll be able to identify in this manner using this key. The key moves from ligule to hairs present on the blade and the sheath, and then any confirming traits. So if we look at yellow nutsedge as the very first weed, the ligule is going to be absent. There's going to be no ligule. There's going to be no hair on the blade or the sheath. So on the leaf blade or the sheath. And then it's going to have a triangular stem, 3 ranked waxy leaves, tubulars at the end of rhizomes. So we'd want to dig these up as well. Typically with the grass, we can just pull them out of the ground. That's going to be yellow nutsedge. If we look at another really common weed in Wisconsin, that's barnyard grass. It's also not going to have a ligule or hairs on the leaves, but the stems are going to be sharply flattened and the leaf collar is going to be yellowish. So again, we lose the rhizomes, we lose that triangular stem, that sedge has an edge, we lose that, and then it'd be barnyard grass. These are easy to identify if we have a seed head. The challenge with grass control is we need to know typically what these are when they're just emerging. So it can be a little bit tricky. So within that scouting guide, there's this whole assortment of grasses to look at has some nice illustrations. You can also find really good photos of these online from many land-grant universities to reference. Again, emerging grasses are tough. They're all going to have these characteristics, even though that grass plant may be only an inch or two out of the ground. They're going to have these characteristics still. You're going to need that hand lens to confirm those to make sure. Most of these are present in many Wisconsin fields, and it's kind of cool to see which grass species grow where. What's interesting to note, though, we typically don't see a huge variety of grasses in a single field. Sometimes it's possible, but typically we see a lot of large crabgrass, or we see a lot of quackgrass, or a lot of fall panicum. So once you start to learn what fields you're scouting and what weeds you have on your farm, you're going to see a lot of the same ones. But again, using these keys, you're going to be able identify many different grasses with. The next challenging weed to identify, and this is really important that we get this right, and that's pigweed ID. So in Wisconsin, we see smooth pigweed, redroot pigweed, palmer amaranth, and water hemp fairly commonly. We also have spiny amaranth in here for reference as well. Essentially, for control tactics, smooth pigweed and redroot pigweed, many of our herbicides are going to work on those, and we don't see that as a huge agronomic challenge to control. Palmer amaranth and water hemp, we will talk about resistance before we're done today. They are a challenge to control because of herbicide resistance, the number of seeds they produce, and how quickly they grow. Similar to grasses, there's some key parts that we need to look at to identify these. For pigweeds, we're going to look at the stem. Is there hair on the stem? That means it's smooth pigweed or redroot pigweed. Again, easy to control, not anything that we need to be tremendously worried about, but we still want to have a timely control of these weeds. If there's not hair on the stem, it's either spiny amaranth, palmer amaranth, or water hemp, which we need to be very concerned about. Now, when they're young, they're going to be a little bit challenging to tell apart. As they get older, the leaf petiole develops and it gets a little bit easier. You're also going to learn what weeds you have in the field. We have a lot of water hemp in the state. We don't have a lot of palmer amaranth. So I'm not going to be too concerned about telling the two apart right now in most cases, but if you have both on your farm, you should start to learn how to identify both, even as they're a little bit more immature. So as these plants mature, the petiole of the plant develops, and that's the part that holds the leaf to the stem. If you can fold that leaf petiole over the leaf and it's longer than the leaf or close to it, it's palmer amaranth. Water hemp has a very short petiole and it also has more of a spear-shaped leaf. Seed head ID can be fairly interesting as well. This the seed head characteristics that I was taught when I went out to Nebraska for some work on this was the seed head of palmer amaranth is going to be is going to be a foot to 2 feet. So it's going to be much longer than water hemp. Water hemp seed heads are going to look much different, and then the seed head of the palmer amaranth is also going to have spines in it. So it's going to be a little bit thorny. Typically not enough to draw blood, but it will be a little bit more sharp. Water hemp will not have that thorny characteristic. There are also male and female plants that can look kind of the same of these. So be looking to see if seed is actually present or not. If they're male plants, they're not nearly as concerning either. But if you have water hemp and palmer amaranth getting this large, it's concerning in itself because it's produced several thousand to hundreds of thousands of seeds. All right, we're going to go through a series of Wisconsin weeds now. All this information is directly copied out of the scouting manual. These are the common ones that I thought were highlights that we should talk about in a little bit more detail. But again, we'll kind of quickly move through this and talk through more things that we should be thinking about as a crop scout rather than just purely focusing on weed ID. But to start off, Pennsylvania smartweed, we're going to talk through lady stem smartweed as well. Smartweed has an ochrea. That's a part of the plant that's on the stem and connects to the leaf. And that's a key characteristic to look for. If we're getting mature weeds later on this season, we can also look at the seeds. Many of us find interest in trying to identify plants by the seed as well. That can be fairly simple to do with some of our more common weeds. But again, typically we know what they are already by the time they set seed. But maybe you have a case where you have some seeds on some equipment, some hay harvesting equipment or grain harvesting equipment, then you could identify what kind of weeds were out in that field. So this is Pennsylvania smartweed. We're going to have pink flowers on this plant. It's going to have that ochrea as mentioned. Move to lady stem smartweed. We lose the ochrea, and we also gain gain a little bit different seed, a little bit different leaf shape. But again, these are going to be very difficult to tell out in the field unless we look for that ochrea on that plant. Common lamb's quarter, this is going to be probably the weed that everyone's seen the most of. Maybe it's surpassing water hemp in some settings, but common lamb's quarter is a little bit challenging to control. It's got a little bit more leaf structure that's a little bit more challenging for herbicides to be attached to. There's a lot of biotypes present, some resistance to herbicides, depending on where you're at. Common purslain's a fun weed. It's a low-growing weed, typically grows in compacted areas. We typically see this in field driveways and field margins where we say park some trucks. They have very linear leaves. They're very fleshy leaves too, so they're like three-dimensional almost. There's a little bit of structure to those leaves. They just look different than most of our other leaves that we see. And then a nice yellow flower. Shepherd's purse is a challenging weed for us as well in Wisconsin. We need to be looking for those lobed leaves out in the field. They have star-like branched hairs on the upper surface, and the leaves lobes point to the leaf tip. So we're going to be looking at a lot of these in early spring, and then they're going to form that seed head that we see later on in the year in those seed pods. Pennycrest is another common weed that I think some can confuse with shepherd's purse, but again, look at there's the lack of the lobed leaves. So we can be looking at the leaves for this, and if we see one of these out in the field, we really need to be paying attention to the leaves because they're going to be troublesome to identify early on in the season. Velvet leaf, this is another one that I think most of us have seen numerous times out in the field. This is very common. Again, the leaf itself makes it more difficult to control because it has hairs on the leaf, and that makes water and herbicides kind of stand off the leaf in some cases. So good surfactants and controlled timing is really important with this. There's also going to be pubescence on the stem, and then a yellow flower as well. But hopefully we're not allowing it to get that big that it flowers. Jimson weed, I just saw a lot of this last night. This is a interesting weed as well. Typically not as challenging control, but it produces a spiny seed that is poisonous. So we don't want this out in our pastures. We don't want anything coming in contact with this seed of the plant. Eastern black nightshade also produces a poisonous fruit. But what's unique about Eastern black nightshade is if we flip over that leaf, it's purple underneath. So that's really key to identifying Eastern black nightshade when it's emerging, because this can look similar to our pigweed species. So we want to pull this plant out of the ground, flip it over, and see what kind of leaves it actually has. That purple is going to be the true um, telltale sign. Burr cucumber is a weed that we start to get some questions about later on in the season because people start to see it. It looks a little bit like grapevine. It takes over patches. It can be hard to combine through. It can be a real nuisance and yield limiting plant in some cases. So I think this is interesting. It looks a little bit like a pumpkin or a cucumber even, obviously similar family. But when it's emerging out in the field, that's going to be the time that we really want to target it for termination. And then it's going to have a cluster of 3 to 20 egg-shaped fruits on it. And they're going to be barbed and prickly. Common ragweed. Common ragweed is a interesting weed as well. They're going to have oval cotyledonate leaves, so there's going to be a very distinct cotyledonate formation form already. The leaves are going to be lacy and finely divided opposite and initially and then alternate. And then the first leaves are going to have 5 lobes to them. So once we see this one, we typically remember it. These again typically take over fields. They're not as troublesome though as the giant ragweed. So the giant ragweed, the cotyledons are going to be oval to spatulate, and these again are going to be very distinct out in the field, and they grow very quickly. So we may have giant ragweed emerging fairly early in Wisconsin, and then have 5 to 8 inch tall ragweed even in mid-May. That was common this year. It's going to have somewhat of a woody stem, and it's going to grow really big, 6 to 14 feet tall. It's going to produce a star-like seed that's kind of cool looking. But again, we don't want to see that seed. That seed will even make it through grain handling systems into the grain tank on the combine and be a nuisance down the line. Horseweed, also called mare's tail. I'll refer to it as horseweed throughout the talk, is an interesting weed for us in Wisconsin and no-till fields. So it has round to ovate leaves. Again, kind of a fine leaf weed that definitely you'll remember as it tends to take over fields as well. And then those horsetail flowers and seeds can travel a long, long distance. And that's how it reseeds itself, and that's how you may get a new population of horseweed out in your field. Keep this moving. We got two more comparisons. We have cocklebur. Cocklebur is not necessarily real common, but it's a weed that we do see a few questions about. It's going to produce that oval burr in the late summer into early fall. And then sometimes it's confused with burdock. And burdock is the weed that produces that wonderful seed head that sticks to pets and sticks to your clothing if you walk through a patch of burdock. We have a lot of burdock here where I spend a lot of my time. It's fairly easy to control, but again, it's a weed that can be easily confused with cocklebur when it's younger because of that similar leaf structure. But the leaves of burdock are going to become a lot bigger, a lot quicker. It's going to be a much larger plant overall. The thistle family I thought was important to walk through. So we're going to talk about four different thistles. The first is going to be musk thistle. And on thistles, it's really important to look at the leaves. Thistles are all going to have thorns. They're going to be kind of nasty plants. But if we look at the leaves, identification of thistles becomes quite simple. So on the leaves of the musk thistle, they're going to have a smooth, waxy gray to green margin with a white hairless midrib. They're going to have spiny edges that extend down the stem. They're also going to have a purple flower to them, but that's not necessarily going to narrow things down for us. Look at the leaf on a thistle. Plumeless thistle, the leaves are going to be deeply divided, and there's going to be hair, especially on the lower leaf surface of these, the midrib, and it's going to be decurrent. There's going to be a plumeless musk thistle flower is going to be purple as well. Bull thistle, this is probably one of the more common thistles that I've seen. This has a deeply cut, spiny margin with a wrinkly surface, and it's going to be hairy. So the leaf is going to be hairy. You can see that in these photos. Really nasty thorns on these as well. Once you see a bull thistle, you'll clearly be able to identify a bull thistle apart from these others because of how much hair there is on the leaves. Again, a purple flower. So the flower doesn't necessarily help us out much with thistle identification. And then finally, Canadian thistle. And Canadian thistle is a troublesome weed we see. It forms in patches out in the fields. It's a little bit different growth and development than other species. So we need to look at primarily look at the stem, and it's going to be hairy on the Canadian thistle. It's going to have crinkly leaf edges and spiny margins, and it's going to be a smooth surface. It looks much different than our other thistle species. And if I had to say anything to compare these, I would say musk and bull are going to be the two that look the closest if we're at a distance. We get close to them, bull thistle is going to be fairly easy to distinguish because of that hair on the leaf. Plumeless is not going to be nearly as challenging because that hair is going to be on the lower surface of the midrib, so we can look at the midrib of the leaf. And finally, Canadian thistle is going to have that smooth leaf surface. This one I threw in there because I've gotten a lot of questions about field equilibrium over time or horsetail. There's a lot of fields in Wisconsin that have this. It's not typically a huge weed problem, but you may see it as little Christmas trees. And I'm sorry the photo's not coming through nearly as clear as I'd like, but they're going to be like little pine trees out in the field. And then they'll eventually, in the second year, develop like a bamboo-like structure, and that's going to be the seed producing mechanisms. It spreads by spores and rhizomes. The stems are hollowed, so those stems we can cut open and they're going to be hollow, and they're going to be a little Christmas tree, little pine trees out in the field. Very common in wet areas. Finally, the last couple weeds, I wanted to highlight curly dock. I see quite a bit of curly dock in maybe some non-crop areas. I think it's an interesting weed. It's going to have about 6 to 12 inch long basal leaves with wavy edges. The stems are going to be smooth, erect, and reddish in color, so it's going to be pretty easy to tell apart a curly dock from other plants when you start looking at different plants in the area. Field bindweed, we're going to walk through a few different weeds now that look a little bit like the same, and they're all going to be vines. Field bindweed has an arrowhead shaped leaf with 3 points. So be looking for those 3 points when you're out in the field. That's going to be field bindweed. We're looking at hedge bindweed. It's going to have 5 points to the leaves. So it's going to be an arrowhead yet, but it's going to have those 5 points to the leaves. So that's going to be a very distinguishing characteristic. So field bindweed, 3 points, hedge bindweed, 5 points, both going to have arrowhead leaves. The final one is wild buckwheat. And wild buckwheat I've seen confused with hedge and field bindweed as well. but it's going to have a heart-shaped leaf with pointed tips. So see that heart-shaped leaf with pointed tips. So no, we lose our points. Black seed plantains, this isn't the only plantain I'm featuring because of time. There's also broadleaf and bracted plantain. Those are common in Wisconsin as well. We typically see these in turf settings, commonly grown alongside, say, creeping Charlie and white and red clover in turf. Um, these are going to be fairly not common in row crop settings, but I did want to still mention it. They're going to be leafless plants with many small inconspicuous flowers. Broadleaf plantain is similar to this, but lacks the purple petioles and has smaller leaves than black seed plantain. Finally, we have dandelion, and everyone's seen dandelion, but we want to be scouting for dandelions as well and making note of that. So our easiest weed to identify is going to be dandelion when it's flowering. You may see some very young dandelions and say, well, is this dandelion or shepherd's purse or some of the other weeds we talked about? But be looking for those lobe points at the base of the plant. The leaves are going to be watery and milky. Juice will come out of those if we cut one off. And then, of course, it's going to have that bright yellow flower. The seeds spread by the wind. So, beyond weed ID, we went through a lot of weeds. They're all in the crop scouting manual for your reference later. But I wanted to talk about things that you're going to see out in the field as crop scouts related to weed control that may be a little bit more challenging than just the weed ID itself. So, and oftentimes we're making a herbicide application, and it's useful to know how wide that herbicide application tool is. Because if you're seeing patterns out in the field that are 60, 45, 90, 130 feet wide, it's probably related to the herbicide application tool. The wind was very important at the time of herbicide application. Having spray records to reference fields around us can be useful if that's available, but wind can create drift conditions. What herbicides were used and if there was any errors. So this is a mixing error where I combined AMS with a very common herbicide and made a ice cream type material that, of course, you would not want to have anything to do with in the sprayer or elsewise. So that can be an issue with weed control if there was errors made in the mixing and the amount of chemical that went in. The spray tip and application technology used makes a big difference. And finally, how big the weeds were. So if we're doing a scouting pass after a herbicide application, again, following those restricted intervals to re-enter that field, and we're seeing weeds that are still alive 2 to 4 weeks after herbicide application, they may look like this plant in the picture, but they may also look like they're perfectly healthy. And that's just because there may be some resistance out in the field, or there may be just the lack of a herbicide wasn't included. Say we forgot to include glyphosate and all of our grass species survived out in that field. So, so, excuse me, herbicide mode of action is an important consideration. There's two free publications here as well. Herbicide classification chart by the United Soybean Board is very useful to look up what the active ingredient is and what the mode of action is for many herbicides. And then there's a free publication from K-State looking at herbicide mode of action that also includes injury symptoms as well. So first off, the mode of action is the metabolic or physiological process impaired or inhibited by the herbicide. It's how the herbicide controls the plant. The site of action is the physical location within the plant where the herbicide must bind to exert its MOA, where the herbicide works. Mode of action is how, site of action is where. So if we look at this chart again, and this did not copy over real well, but it's a fairly lengthy chart with many, many herbicide choices on it. We can start to look at this for a little bit more detail. So on this mode of action chart, it gives us a site of action group number. That's going to be on our herbicide labels typically. It's going to give our site of action. It's going to give the number of weeds resistant to this product, the chemical family, the active ingredient, the product trade name. These two are going to be the most important for us typically as crop scouts. Sometimes the site of action group number can be useful as well, but we're going to be interested in what was the active ingredient applied or what active ingredient are we going to apply because all that has different symptomology out in the field that may be causing herbicide injury. We're going to need that active ingredient to look at those publications that tell us what the injury should look like. Typically, product trade names are not used because there's many trade names for some of these products. We also have combination products. So on this chart as well, and on the herbicide label, so the herbicide label is probably the first recommendation I would have for you for this information. But if you just had names thrown at you and you wanted a quick reference to herbicide, chart would be. And of course, you have to read, follow, and understand the herbicide label if you're actually the one applying it and recommending it. So we have Acron here, not an endorsement of any of these products shown, but it has four active ingredients. They have trade names for some of those and then site of action group numbers. So if you're seeing some mesotrione injury, well, an Acron was included, it could be Acron, but mesotrione could have been included in another product sprayed as well on that particular field. Herbicide resistance is also another really important thing to think about as a crop scout. Signs of herbicide resistance out in the field are weed species are labeled for control and application is made at the correct height. Weeds survived. There was no herbicide application errors. The environment was favorable for good herbicide performance. Only one weed species escaped. Example, water hemp. Weed is healthy while neighboring weeds of the same species have died. Again, you can see water hemp, different biotypes out in the field, unfortunately. Respraying did not control the weed. That's a huge mistake. I every summer I get numerous stories about, well, we went out and we resprayed again. And that was on the assumption that there was an environmental factor or there was an error made in the herbicide application. Resprays cost everyone a lot of time and money, so I would really carefully evaluate respraying. The weed was not controlled in the same patch in the past. The patch is getting larger. Water hemp again. Weed was not controlled by different herbicides within the same site of action in the past, and the same site of action has been used frequently. So always using that same herbicide. In Wisconsin, we've got quite a few different cases of known resistance. I just asked Dr. Rodrigo Worley if there was an update on this. And in 2025, we have PPO resistant giant ragweed. We have 2,4-D, HPPD, and PS2 water hemp. So those are all site of action groups. And then the latest research is showing concerning novel resistant cases, and more information will be released very soon. So if we're using some of these herbicides, for example, HPPD inhibitors on palmer amaranth may or may not be effective. And again, remember, these are populations of weeds. So this isn't always universal, but pretty universal. We're seeing some big challenges to glyphosate and our group 2 herbicides on water hemp in particular. Those we really or group 14 rather. I was looking at the wrong thing. Group 14 and glyphosate are two most common. Group 9 when we think about eliminating those from our control options for water hemp itself. But they still have good reason to include those in some of our herbicide mixes, though. Pesticide drift. This is unfortunately common that we see as crop consultants. The photos from the Whiskweeds lab trial a few years ago using smoke bombs on the back of a sprayer showing the wind. That wind, I do not know what speed it was at that day. I don't have the details on that application. This was a part of a research study, but you can see that particle drift moving within the width of the sprayer, but if it was windier, you'd see that moving quite a bit further, unfortunately. So when we have drift, we have isolated injury to an area that may have received an unintentional herbicide application. This could be near fence rows, road ditches, lawns, and other crops. This is particularly sensitive to, say, tomatoes and grapevines, especially with a lot of the growth regulators we spray now. We have particulate and vapor drift. So particulate drift happens at the time of application. That's that smoke that you see. That's those fine particles moving. Vapor drift can occur later on. If there was a temperature inversion, it can actually pick that herbicide back up and it can move it to injured crops later on. And there's usually a distinct pattern of injury present. So it's a kind of a trailing off area into the field. It's not going to be 60 foot wide or whatever our spray equipment was. It's going to be a very variable pattern typically. So looking at herbicide injury more out in the field, we spend quite a bit of time looking at this in the experimental setting, but also in the training setting throughout the summer. So that, again, two resources I recommend are the Herbicide Mode of Action booklet from K-State. And then we have a publication that, again, is in the Crop Scouting Guide, the Herbicide Side of Action Key. So we're going to go through that key in a little bit more detail the last few slides of today's talk. But we have two things to look at. First, it's injured at emergence. And this is when the plant absorbs a herbicide from the soil, either as a soil-applied herbicide or carryover. The roots are normal with damaged shoots, or the roots are damaged, resulting in stunted plants. That is the injury that I'm showing there in the photo. We have then injured after emergence. The herbicide has contact activity with older leaves resulting in injury, or the herbicide translocates, like glyphosate, systemic activity, to the growing points, root tips or meristems, with new tissue showing injury. So herbicide injury is going to be difficult to identify. When application history is unknown or drift occurred, typically a pattern of injury has taken place. Weather conditions at the time of and after application are important considerations, and genetic susceptibility of the crop and herbicide resistant traits present are also really important keys to the story. So if we look at herbicide injury at crop emergence, the soil applied herbicide could be create an issue. This would be more common in soybeans. We see a lot of herbicide injury in some cases, or herbicide carryover. Herbicide carryover is going to be tough to track down in some cases. So there's a lot of info on here. I'm not going to go through all the details, but a few things to look at. We want to look at the roots. We want to look at the shoots of the plant. We want to look at the leaves of the plant, and all those will add up and tell a story. Um, there's some really interesting things that herbicides do to a plant. And we typically look at color, we look at the leaves to see those stories. So if we're seeing drawstringing of the leaves, this is a fairly common injury that we see. A long chain fatty acid inhibitor or a group 15 herbicide did that. So again, referencing back to the herbicide chart to see, well, what are our group 15 options? Were any of these applied? We can see some injury to the roots from ALS herbicides or from microbial tubule inhibitors. And then finally, we see some bleaching occur from group 27 herbicides. Group 13 also does this as well. So we can start to pick up on some of these visual injuries out in the field. Now, if the injury occurred after crop emergence, post-emergent application issues, tank contamination, drift, then this is tougher to track down in some cases. But again, similar symptomology. So we have our contact activity. We're going to see the spots from the herbicide actually on the leaf. Kind of cool to see. We have our non-selective herbicides as well. And then we have our translocating herbicides that are going to injure that new growth. Older leaves may not be injured. So we have our cupping and epinasty and leaning. These are going to be synthetic auxin injury or group 4. This is probably going to be the more common injury that we see out in the field, unfortunately. I saw some of this spring even. If we have some reddening of the veins or the outer leaf margins, we're going to have a group 2 herbicide. Our ESPS synthase inhibitors, our group 9s are going to have some interesting symptomology on non-resistant crops and eventually leading to death. Our HPPDs are still going to cause that bleaching symptomology. So whenever we see bleaching symptomology, we can be thinking of those HPPD herbicides or our group 13 herbicides. HPPD is going to be more common though. And then our ACCase inhibitor herbicides are going to kill the meristem and it's going to rot. So we can actually pull the stem out of a corn plant sprayed with Select and it will actually be dead long before the corn plant looks like it. So that's kind of a cool tactic to use. A couple of bonus slides as we enter our last few minutes together. Recommendations. So if you're scouting a field and you're also asked to make recommendations, University of Wisconsin publication A3646 is updated annually with weed rating data for corn, soybeans, small grains, and alfalfa to provide some recommendations. There's going to be pre-emergent herbicides and post-emergent herbicides. The word of caution on the pre-emergent herbicide rating table is that's for in some cases weeds that are not emerged yet. So pay attention to those rating tables. Post-emergent ratings would be timings when we actually spray when the weed is up. And then finally, we have a lot of water hemp management issues in the state of Wisconsin. So we have some dedicated publications to water hemp management as well, doing some summaries looking at our research over time. Spoiler alert from all that research is as a really good pre-emergent herbicide goes a long ways in controlling your water hemp. Our water hemp is fairly easily controlled with a pre-emergent herbicide in a soybean system. Post-emergence gets much more trickier. So again, if you are tasked with developing those recommendations, there's many resources available. Feel free to reach out to us as well. Remember, uncontrolled weeds equal future expenses. So there's Palmer amaranth growing in, unfortunately, Nebraska hay bales. We have giant ragweed at the Janesville farm taking over a corn crop, causing severe yield injury, and even a farm near Lancaster had water hemp growing on the hay wagon. So think about the plan. Good agronomic planning equals success. As crop scouts, I challenge you to always go out in the field with a spade and a magnifying glass, dig up some plants, look at the plants, examine them, see what's going on out in the field. Think about all the different interactions that could be occurring. Again, typically we're scouting prior to a weed control pass. If we're out there after a herbicide was applied or after a weed control tactic was applied, then we're troubleshooting and we're becoming detectives because there's probably a herbicide injury going on, or maybe there was weeds not controlled. That's the more challenging side of weed scouting for pest management purposes. So with that, I would welcome questions via phone, text, email. Um, we also have our evaluation survey there. We'll leave that QR code up. And then finally, we've got another slide on the next steps of this series. We got a couple things entered the chat. I believe those are the resources coming in, but I'll check that. Yeah, so Liz also put in the survey QR code, so we'll continue moving. Thanks to Jordan for putting in those resources for us as well. We'll continue moving forward here. So our next step on June 17th, we're going to learn about common crop diseases. And then we have in-person field days to look at this stuff more in the field. So we're going to be having a session at Lancaster on June 18th, Arlington on June 27th, and then finally on the 27th of June at Marshfield. Continue to follow up on the website for more details. Our next Lunch and Learn is again, as I said, June 17th on crop diseases. So welcome anyone to unmute. I'm going to stop sharing and we'll take questions and comments. Liz has in the chat, is there a point of action with resistant weeds that scouts should be aware of? When to report susceptible resistance? Yes. So anytime we're thinking about a case of resistance, I would recommend sending an email to Dr. Rodrigo Worley in most cases. Also Dr. Mark Renz, depending on if it's a forage crop or a field crop. If we have a susceptible resistance in a vegetable crop, contact Dr. Jed Calhoun, all University of Wisconsin-Madison professors. In many cases, resistance is going to be tough to identify and tough to test for. There's going to be some testing options through molecular testing options that we pay for, as in if we have the weed, we would pay for it as crop consultants, crop scouts. Um, there's also going to be some greenhouse studies taking place over time at the university. So the Weeds Lab, led by Dr. Worley, has done quite a bit of testing of water hemp over time. That's where those updates came from today. I would imagine that that would continue. So you'll occasionally see calls for weed seeds to be sent into the university to have those tested in the greenhouse. Otherwise, looking at field history, looking at things that have been done over time may help guide to say there's a possible case of resistance, but really doing a dose response is critical. The point of action would be if you're seeing weeds escaped, say 4th of July or later on in a typical row crop setting, and then you've applied the same herbicide chemistry over time, I'd rotate options and challenge yourself to find some new tools for the next season. Using tools like Winter Rye can be as effective as adding another herbicide side of action group without actually adding another herbicide side of action group into the crop rotation. So I would be thinking if I've still got weeds out there after I've done a two-pass program or a multi-layer row cultivation program, I've still got some troublesome weeds. What am I going to do differently for next season? If I've been using herbicides, I've got a lot of weed escapes. I know I've done everything correctly the last few years. I would take some action to think about what could we be doing later on. In season, that's tough. We can be thinking about if it's soybeans, maybe the weed zapper to reduce populations, some row cultivation to reduce populations if the soybeans are still small enough. Um, some hand roguing can work. And then finally, we want to make sure that we don't spread those weed seeds to other fields in the fall. So we want to be cleaning our harvesting and tillage equipment.
Got a question for you, Dan.
Yeah.
So you mentioned the horseweed was a problem in no-till primarily, if I got that right. Why is that the case?
Yeah. So that seed blows in from another field or from another plant and then sits on the soil surface and then quickly grows. Any sort of tillage typically eliminates that seed from taking off, and it's no longer an issue.
Gotcha. Thanks.
Good question. All right, Liz and Jordan, anything else for today?
I think we're good to go.
All right. Well, thanks everybody for coming today. Everybody must be out in the field. It's a quiet group.